Nalla Narasimha Reddy, Education Society's group of institutions, integrated campus. Welcomes all civil engineering students. This is Dr. G. Subbarao. In this session, I am going to discuss about cleavage and fracture as a part of physical properties of minerals from Unit 2 Mineralogy. So let us study the physical properties of minerals in detail. Physical properties of minerals. In the previous class, we studied some of the properties, and in this class, we go for cleavage and fracture. Cleavage. Cleavage is the tendency of a mineral to break, particularly along smooth planes which are parallel to the weak zones of a mineral. So, cleavage means it is the tendency of a mineral to break along the smooth planes which are parallel to the zones of weak planes in the mineral. In geology, cleavage describes a type of fracture that develops as a part of deformation metamorphism. So, in geology, cleavage is nothing but a feature that develops as a result of deformation and metamorphism. Cleavage is a physical property which is studied by geologists and civil engineering students for mineral identification, of course, both in hand specimen and also microscopic examination of rock and mineral space. As an example, the angles between the prismatic cleavage planes for pyroxene mineral is 80 to 92 degrees. If we study the prismatic cleavage planes of pyroxenes under microscope. But similarly, amphibole minerals, which shows the prismatic cleavage planes between 56 to 124 degrees. These are diagnostic features for identifying whether it is a pyroxene mineral or amphibole mineral. Hence, study of cleavage both in hand specimen and microscopic examination helps to some extent to identify the pyroxene group of minerals and the amphibole group of minerals. Depending upon the atomic structure, some of the minerals will exhibit one set of cleavage and some other minerals exhibit two sets of minerals. Some more minerals exhibit three sets of minerals, cleavage plates, and some minerals exhibit four sets of cleavage or even sometimes six sets of cleavage. There are minerals where even cleavage is absent. That means no cleavage is noticed. So this is to be helpful for identifying some of the minerals based on whether it is one set of cleavage or two sets of cleavage or three sets or four sets or six sets and even absence in case of some of the minerals. Let us see the table. There will be no cleavage at all. So cleavage will not be displayed by the minerals, especially quartz, flint, jasper, olivine, garnet, hematite. So these minerals never exhibit cleavage. So this is one indication. And cleavage is indistinct in case of pyrolusite, graphite and upright minerals. In some instances, one set of cleavage is present in case of mica, chlorite, talc and asbestos. Similarly, Two sets of cleavage can be identified in feldspars, hornblende, kyanite and agate. And finally, three sets of cleavage can be seen very clearly in calcite and galena minerals. Let us see how the minerals which exhibit cleavage of one set, that means in one direction, the planes, the weak planes can be identified. Best example is muscovite, so that we can remove the layers of muscovite one by one with the help of a pin. This is another mineral, gypsum, where cleavage is one set. So in one particular direction, the cleavage, the layers of gypsum can be removed. And if we study feldspars, so cleavage can be seen in two sets. That means in two directions perpendicular to each other, where the weak zones can be identified, so that we can notice two sets of cleavage in feldspars. It's another example, feldspar in a different mineral. Three sets of cleavage. So that means cleavage in three directions at right angles, 90 degrees. That is called cubic cleavage. It exhibits by halide, and the same three sets of cleavage can be seen, but not right angles. That is 120 degrees and 60 degrees. This is called, rhombohedral cleavage. However, three sets of cleavage can be seen in case of halite mineral and calcite mineral. Halite. How the cleavage, is exhibited by the mineral halite. Calcite. Three sets of cleavage in the picture can be seen very clearly how they are. Since the atomic structure of a mineral is definite for each and every mineral, the cleavage character for each and every mineral will also be definite. Depending upon the degree of perfection, cleavage may be even described as perfect or excellent. Instead of one set, two sets, three sets, four sets, we can say perfect cleavage or excellent cleavage in case of mica, or we can say good cleavage in case of calcite. The poor or indistinct cleavage can be seen in case of apatite mineral. Even in such a way, cleavage can also be described as perfect or excellent, good, poor or indistinct. Prismatic cleavage. This occurs when there are two cleavage planes in a crystal. Best examples are spodumene, chumolite. These minerals exhibit two sets of cleavage, and we can call it as prismatic cleavage. This is called octahedral cleavage, which occurs when there are four cleavage planes. Best example is fluorite. Four cleavages can be seen here in case of fluorite mineral. And cubic cleavage, galena, halite, where three cleavage planes intersecting at 90 degrees, so that the resultant cleavage is called as cubic cleavage, which is exhibited by galena and